In section 9.8, we'll be simplifying expressions. The key to simplifying expressions is to find like terms and combine them. So, for example, if I had 3x plus 2x, those are like terms. They're both x terms. They have the same variable. And so I can combine those and say if I have 3x's plus 2 more x's, that's 5x's. However, if I had 3x squared plus 2x, well, my 3 is an x squared term and 2 is an x, so I can't combine x squareds with x. They're different terms. So those would not be combined. They're already simplified as much as they can be. So 3x squared plus 2x would stay 3x squared plus 2x. Also, if I just had 3 plus 2x, and 3 is just a constant, 2x has an x term, and so those cannot be combined either. Okay, so keep that in mind whenever we are looking at the following examples. So example A is 9k plus 12 minus 5. So there is not another k to combine with 9, but 12 and minus 5 are both just constant terms. So I can solve that part first. So 12 minus 5 is 7. Bring down my 9k and my plus sign. And then 9k plus 7. Well, those are not like terms. They can't be combined any further. So this expression, 9k plus 7, is in simplest form. Okay, on B, recall the distributive property. Whenever we have a number outside parentheses, we multiply that to each term inside by distributing. So that's going to be my first step. So I'm going to multiply 3p times 7. So 7 times 3 is 21p plus 7 times 2q. 7 times 2 is 14q. Okay, now looking at combining them, one term is a p term and the other is a q term. Those are not alike, and so I cannot simplify those any further. Example C, we will start with multiplication because, again, I'm using order of operations, so PEMDAS says I'm going to multiply before I add. So we'll use a distributive property. So I'll multiply 5 times 3z is 15z, and 5 times negative 1 is negative 5. Bring down my plus sign and my 2. So now I'm going to look at combining like terms. So my 2 is just a number by itself, a constant. So I can combine that with another constant. So 2 plus negative 5, make sure you keep that sign with the number. So 2 plus negative 5, positive 2, negative 5. I would cancel pairs, so I have negative 3 left, plus bring down my 15z. Now since 3 is a constant, does not have a variable, 15 has a variable z, those are not like terms, so I would leave it like that. Now notice that addition is commutative, so you can write it negative 3 plus 15z or 15z plus negative 3 or minus 3. Both of those are correct. It doesn't matter which order you put it in. Okay, on example D, recall from a previous section that anytime we have a minus in front of the parentheses, we put a 1 and distribute the negative 1. This is a very important step and one that a lot of students forget to do. So I'm going to start again with distributive property. So parentheses should be a clue that you start with distributive property most of the time. So put your 1 there. So negative 1 times 2 is negative 2. Negative 1 times 5y is negative 5y. Now this minus sign came down already when I multiplied it as a negative, so I'm just bringing down my negative 3. So I have negative 3 minus 2 minus 5y. So like terms would be my negative 3 and my negative 2. So if I have negative 3 and negative 2, there's no pairs to cancel out, so I can combine those. If I owe $3 to one person, owe $2 to another, I owe 5, so it's going to be a negative 5 minus 5y. Those two terms are not alike, so it is simplified at that point. Okay, example 2 is asking us to give the numerical coefficient of each term. The word coefficient means a number multiplied to a variable. Well, when we write multiplication between numbers and variables, we just write it in front. So, for example, 5x is 5 times x. So the number multiplied to the variable is the 5. So you can look at it as the number in front of a variable. So on A, 15q, the coefficient would be the number 15. B, negative 2m cubed, the coefficient would be the negative 2. C, negative 18m to the 7th q to the 4th, the coefficient would be the negative 18. So it's just taking the numbers that are in front of the variable. Okay, D, negative r. Well, I don't see a number in front of the variable. Whenever you don't see a number, it's a 1. So negative r is the same thing as negative 1 times r. So my coefficient would be negative 1. Same thing as if I just had x. If I had an x by itself, that's the same thing as 1x. So my coefficient for just a variable by itself would be 1. Okay, and our last example, E, 5x over 4, is the same thing as 5/4 times x. So the coefficient would be the fraction 5/4. Example 3 goes back and relates to what we discussed in example 1 as looking at terms as like or unlike. So A, 9x and 4x. Those two terms are like terms. The variables are exactly the same. We would be able to combine those. B, negative 8y cubed, 12y squared. Well, because my exponents are different, that makes those unlike, and I would not be able to combine those. C, 5x squared y to the 4th, 5x to the 4th y squared. Well, I have x squared and x to the 4th, y to the 4th y squared. The variables are the same, but their exponents are different. That makes them unlike. They have to be identical in order for them to be like terms. D, 7x squared. So I have x squared and x squared, y to the 4th and y to the 4th. So it doesn't matter what the coefficients are, the variable parts are identical. So those are like terms. And E, 13kt and 4tk. Now remember, multiplication is commutative, which means you can write it in any order, meaning 6 times 4 is the same thing as 4 times 6. So on E, k times t is the same thing as t times k. So this could be rewritten as 13kt and 4kt, which would make them like terms. In example 4, we will be combining like terms. So A is 4k plus 7k. Since those two terms are alike, we can go ahead and add them. So 4 plus 7 is 11k. B is 4r minus r. So recall, if we don't see a number in front of a variable, we put a 1. So 4r minus 1r is 3r. C is 5z plus 9z minus 4z. So all of those are exactly alike. So 5z plus 9z is 14z. Bring down my minus 4z. 14z minus 4z is 10z. D, I have 8p plus 8p squared. Well, p and p squared are unlike terms, so I cannot simplify this any further. So this would just stay 8p plus 8p squared. There's not a way for me to simplify it. And e, 5x minus 3y plus 2x minus 5y minus 3. So I'm going to combine like terms together. So 5x plus 2x is 7x. And then negative 3y minus 5y. So negative 3 and minus 5 is a negative 5. So if I have 3 negatives and 5 negatives, that's negative 8y. And then I have my minus 3 that doesn't combine with anything. So 7x minus 8y minus 3 would be my simplified form of that expression. Okay, example 5. We're going to simplify the following expressions. So A, I will start with the distributive property. So 3 times 5 is 15. 3 times 2p is 6p. Bring down everything else. Okay, now I can combine like terms. So I have a 10p plus 6p is 16p plus 15. B, again, I'm going to start with my parentheses. I have a minus in front of that, so I'm going to distribute the negative 1. So negative 1 times 1 is negative 1. Negative 1 times z, negative z. Bring everything else down. Then combining like terms, I have 7z minus z. So that's a minus 1z. So 7 minus 1 is 6. And then negative 2 minus 1. Negative 2 minus 1. There's no pairs that cancel, so I have 2 negatives and 1 negative gives me 3 negatives. Okay, and C. Again, a negative in front of the parentheses. Distribute the negative 1. So that's negative 3k squared. Negative 1 times 5k is minus 5k. Distribute the 7, so plus 7k squared. 7 times negative 4, negative 28k. Then we'll combine like terms, so negative 3k squared plus 7k. Negative 3, positive 7. So I have 3 pairs that would cancel. I'm left with positive 4k squared. Negative 5k minus 28. They're both negatives. Nothing cancels. That gives me a total of 33k negatives. Example 6 on page 663. Write each phrase as a mathematical expression and simplify by combining like terms. So 3 times a number is going to be 3 times x subtracted from, remember subtracted from is one of my 4 terms that switches the order. So I would have my 3 times x subtracted from, so in the back, the sum of the number and 8. So sum means add the number plus 8. So I have the number plus 8, x plus 8, minus 3x. And I put the parentheses, but in this case you actually don't have to because order of operations would have me add the x plus 8 and then subtract the product of 3x anyways. So Either way, with or without parentheses, would still give you the correct answer. On B, twice a number. So twice a number means we're multiplying by 2, so 2 times x. Added to is another one of the 4 keywords that switches it. So that means I would put plus 2x. The sum of 6 and the number. 6 plus the number. And again, order of operations would have me find the product of 2 and x and then multiply in order, so I don't need parentheses. If you wanted to put parentheses, that would be correct as well.